Okay, I'll be talking today about post-processing of biochars to enhance plant growth responses. So you've got some biochar. You're a biochar manufacturer. You've produced this lovely black substance. What do you do now? Many companies are looking at processing. So either sort of passive processing through aeration or leaching, or potentially heat treatment, or grinding of the material. There's other options, chemical modification and so forth, but I'll be focusing here on physical processing. My lab has done quite a bit of work on this really as a necessity. We find that a lot of biochars, for example, have mobile organic compounds that are condensed on the chars during the pyrolysis process. And these can have really detrimental effects on plant growth responses. So it's wood vinegars, for example, but a variety of things. So either leaching or heat treatment is oftentimes necessary to really get good responses. The other thing that's interesting, I think quite important, is looking at particle size. And I've done a couple sets of experiments looking at particle size effects on plant growth responses, and there can be very large responses. And interestingly, plants may respond quite differently. There's some plants that prefer different particle sizes than others. The other thing to pay attention to is that processing, things like sieving, can affect not only the particle size, but the particle's shape. So you get changes in aspect ratio, for example, that may be quite important. And finally, we've begun to work with a couple companies looking at granulation and pelletization, and have some really promising responses here, for example, with green roof applications. This is a case where you really don't want char to be blowing off onto your neighbor's property. And it also looks like granules can do quite a good job in this system. So categorizing these kinds of post-processing treatments, you can grind or otherwise manipulate particle size. You can have kind of cleaning treatments, leaching or washing or aeration, that are designed to get rid of mobile organic compounds. Heat treatments may do a very similar kind of thing, particularly with aeration. Activation is an option. And then finally, pelletization or granulation, which is usually motivated more by handling and dust reduction concerns. So what comes out? We have now more than 100 kind of observations to work with across quite a few studies. And if you look at the net effects on plant growth responses, so plant biomass responses, post-processing in general is beneficial, but there's a couple of those treatments that stand out, and that's reduced particle size and heating and aeration. Leaching treatments and activation treatments, in fact, don't seem to have any net benefit, and there's really not enough data right now to say very much about granulation or pelletization. So these are above and beyond the responses we find just from using biochar. So you can take a 27% increase and turn that into, say, a 40% increase. Particle size effects also give a really interesting and clear story. And that's that there is an optimum particle size. And that optimum particle size looks like it's between about 0.5 and 1 millimeter. Very small dust-sized particles don't give as good a response, and neither do larger sized particles. So just a few take-home points from that. Post-processing looks to be, in general, a good idea for enhancing biochar properties as measured by plant growth responses. Reducing particle size and heating or aeration treatments stand out as having the most consistent positive effects. Looks like there's an optimal particle size of a little less than 1 millimeter. Activation and leaching treatments don't appear to be as beneficial. And now we just don't have enough data on pelletization or granulation to really make firm statements. And I want to highlight this area as something really important for future collaboration with the industry, with engineers, and also with soil and plant scientists. So thank you very much.